Alright guys, welcome to PreCalc 116. So this is going to be a bit more of a personal activity. It's going to be a relatively short video, but it's going to be a lot of time with you guys kind of working independently here. So what I'm going to do is I'm going to give you, let me change that, there we go. Okay, so I'm going to go ahead and give you guys this PDF. It might be hard to see all of them in this one view. I'll try and zoom in to, like, if we go to maybe 75 too much. Can I see all of them? Let's try like a 70. I just want to get so I can see all of them. Oh, just barely not. 65. This is the last one. Yeah. Okay, so there's all of the different values. So you want to try and find out of those 21, pair them off or group them, because there are going to be some groups of like 3, into equivalent expressions. So you want to say, hey, well, this term and this term are the same, so I'm going to pair those off. So you're going to have 9 total, and some of them will have 3, some of them will have 2, so it's 9 total groups. Pause the video, try and group those up as best as you can. Once you think you have it, you have all 9 of those groups, then go ahead and resume the video and you can check it with me here in a second. Alright, so to check those, I have them kind of here. So our first group is going to be these two, right? If we actually FOIL this out or distribute property this out, let me zoom in a little bit for these ones so you can see it a little bit larger. So if we just distribute this out, and if we multiply this out and then distribute that through and reduce, we actually end up getting equivalent expressions on those two. So that's one pair. Then we have these 3 here. So on these ones, they all have that kind of x minus 1 on the bottom. If we change this into 2 times x minus 1 over x minus 1, and we kind of join it in, and same thing here, make this x minus 1 over x minus 1, and we combine these, we're going to see equivalent expressions. Also, if you multiply this x minus 1 squared out and then kind of combine some like terms, you're going to get that same expression there. The next grouping that I have, these 2 here, this kind of requires you to kind of use that properties of fractional exponents and knowing that those are equivalent to radicals. Then we have the pairing here, right? So again, if I take this 2 and make it x minus 2 times x minus 1 over x minus 1, then we can combine and get one fraction, and you should get this as your equivalent fraction there. All right, over here we got these 3. So on these ones, this is really just kind of showing a factoring by parts. Your instinct may be to go, hey, let's take this and combine those, which is fine. But if you factor out an x from those 2, factor out a 5 from those 2, you're going to get this. And then if you factor by parts this and factor out an x minus 1 from this term and this term, you end up getting this fully factored form there. So I just wanted to kind of show you guys that one. Then we have the grouping here. So this is a kind of more tricky one, mostly because of this part here where we have like a fraction inside of a fraction, right? If we multiply this by the fraction x over x, it really cleans things up quite a bit, and then you end up getting effectively this, which if you factor the top with a difference of perfect squares, and then you can cancel that out, and then you're left with just a 1 with what's on the bottom, and you're left with just a negative 1 minus an x. All right. Next pairing, we have these ones here. So again, these negatives on the exponents can be kind of messy, but if we deal with those, we end up getting left with just this. Then over here, if we take this and say, well, those rad times itself is going to be the rad of x minus 1 squared, the square and the rad are going to cancel out and leave you just the x minus 1. That one's not too bad. And then our final pairing is going to be these ones here. So again, if you take these terms here and get them into common denominators, so multiply 6x by x minus 1 over x minus 1 and 1 by x minus 1 over x minus 1, and then combine them all into one big fraction. This is what you end up getting. So those are our 9 pairings. Okay, so that's effectively it for today. Note-wise, here's point slope form. This is a form that you've probably seen a bit in the past. You've used it. It's really just kind of a modification of the equation for slope. If you were to actually take this side and divide it by x minus x1, you would just get the equation for slope, y2 minus y1 over x2 minus x1. That's where it comes from. That's a very useful formula if you are given a point and a slope, hence it being called point slope form. I'm not going to spend a lot of time on that because, again, it should be something not terribly hard for you. Right, so last thing is I want to talk about with some of these expressions. Were some of those only equivalent for certain values? Meaning, are there certain cases, certain values of x, which would not work in making these things equivalent? Right? So go back and look at your groupings and say, hey, are there any values of x which would actually not work? Right? And then pause it and try that out, and then come out here now. All right. So if we look at a thing, let me find one that's good to demonstrate this. There's some here. Here's a really good one. Okay, so on these two, right, the domain of this is everything, right? Every value of x works here, right? But here, does every value of x work, right? Well, if I were to do x being a negative, I'm going to get imaginary numbers out of that. They would eventually turn into this and work out, but this has a domain that is a little bit different than the one here. The other big case we want to be watching for are these all have equivalent stuff, stuff like this. Whenever we have these fractions, right? Here's what I was looking for, right? So the pairing here, right? This is the kind of prime one. So this bottom one, domain is everything, right? All real numbers work, right? Here, the value which doesn't work is x can't be 1, right? So if x is 1, these two things are no longer equivalent, but they're equivalent for everything else except when x is 1 because this becomes undefined there. Likewise, if I go over here, well, now x can't be 0, right? But x still can't be 1 because if x is 1, the big fractions bottom is 1. But if x is 0, those little fractions bottoms are now 0. So I can't be 0 or 1 for this to be equivalent to this, and I can't be 1 for these two to be equivalent. So those are just kind of the introduction to our kind of what are called domain restrictions. It's values which it works for everything but these specific cases. So just wanted to kind of point those out to you guys. All right, so with that, here is our assignment for today, 55 through 61, and I will talk to you guys next time.